Question 1a, we're going to use algebra to solve that equation from negative 360 to 0, and then write the general solution. So besides the fact that says write the general solution, this is really a grade 11 question. The question is in degrees. We want to solve for x. We have a little bit of rearranging to do, and that I can move the 5 over to this side, move the 2 sine x over to that side, divide both sides by 2 to get sine x by itself. Now the difference from now and grade 11 is now you have these values memorized so well. Is 1 on your pie plate? Yes. When is your y coordinate equal to 1? At pi over 2, but this question's in degrees, so 90 degrees. Now you will start to naturally do this. Is that the only place between 0 and 360 that it's equal to 1? Yes. You will naturally solve between 0 and 360 degrees. You'll actually start to naturally solve between 0 and 2 pi. You'll start to do things more often in radians than you will in degrees. But you just normally solve from 0 to 360 or the first time around the circle. We have to be careful in this case because the domain that they gave us was from negative 360 to 0. So that's your first negative angle. So you'd have to go back here and put a line through this because this isn't our actual solution because that answer is outside of our domain. What's coterminal with what's coterminal with 90 degrees but a negative angle? Negative 270 degrees. So we've solved it between negative 360 and 0. It says also to write the general solution. And the general solution for this one would be, there's only one answer between 0 and 360, which is 90 degrees. And since we're in degrees, we'll do 360 degrees times k to get all the coterminal angles. Part B, use algebra to determine the general solution and list the roots from negative 2 pi to 0. Okay, so we've got cos 3x cos 3x equals negative 1. Now this question's asking us to do the general solution and list answers in a certain domain. So I'm going to use method 1 where we first solve between 0 and 2 pi. So if I make x between 0 and 2 pi, then step 1 that we did was we said write your domain for 3x, which would be between 0 and 6 pi, and then solve for 3x. When is the x value on your unit circle equal to negative 1? That's at pi. That's the first time around. Second time around, 3 pi. Third time around, 5 pi. We go 3 times around because 3x is between 0 and 6 pi. And then we can solve for x, divide each of these by 3. These, again, are solutions between 0 and 2 pi. Once you have your solutions between 0 and 2 pi, it's easy to write your general solution. Your general solution will be x equals each of these three, pi over 3, pi, and 5 pi over 3, plus 2k pi, plus 2k pi, plus 2k pi. Where k is an integer. It said after writing the general solution, can you write your solutions between negative 2 pi and 0? Well, we figured out our solutions between 0 and 2 pi. If I draw my unit circle here, we had one solution at pi over 3, one at pi, and one at 5 pi over 3. So if I wanted to write those same angles in negative, can you see that this one would be negative pi over 3. The next one is really easy to see, would be negative pi. And the one in quadrant 1, if you went in the negative direction, would be negative 5 pi over 3. I felt it was easier to see these negative angles between 0 and negative 2 pi, having first solved between 0 and 2 pi. Because then you'll find all the angles in the first time around in the positive direction. Then to convert those to angles that are negative is fairly easy. All right, questions for practice on this one? 4, 8, and 9.